Hello guys, welcome to my channel Engineering Insights. So in this video we are going to see how to create a CAD model for universal coupling in Creo Parametric 8.0. This video is going to contain three different sections. The first section going to cover how to create a parts of universal coupling part by part. In the second section we are going to see how to create an assembly of universal coupling. And in third section we are going to see how to assign a mechanism and to see how it is going to work in the applications. So without any delay, we'll get into the video. So as in the screen, you can able to see a 2D drawing of universal coupling where we have all the parts in individual. So I'm going to use this drawing as a references for us to create a universal coupling, and we are going to start the CAD models. Let's begin. So first I'm going to click on a new command and I'm going to create a part. The first part I'm going to create a fork which is made up of cast iron material, and the number of quantity required is 2. So let me create a fork here, and I'm going to use the same dimensions which is applicable in the drawing. So here we can just analyze the drawing. First we have a LF structure and along with a shaft. So I'm going to take this top view. From the top view I'm going to execute this model first. So for that I'm selecting a extrude command, selecting the top plane, and I'll just click to sketch view. I'm going to create before creating a circle I would like to have a center lines here, and I'll disable all these planes, center lines, axis lines, everything. Yeah. So next I'm going to create a circle. So the diameter is 88 mm, and I'm going to draw a straight line which is symmetric in the horizontal axis, and this is also would be like as 88. So I'm going to remodify this as 60 and this will be as 88. I'm going to have a straight line for 30 and a tangent line for the circle. So I'm going to create a tangent line here as well as a straight line for 30 mm distance and a tangent line for the circle. Now I'm going to delete these unwanted lines in both top and bottom. So next we are going to define the horizontal lengths. The total length of the coupling is 130. This distances would be like, so the shaft can be considered as center line is from 100. I'm going to consider this value as 100 so that I may have 30 mm extra distance for the length of the shaft, or else we can take it 50 as the length of the shaft. So this value will be like 130 minus 50, which is equals to 80. So this looks fine. So these are the dimensions which we constrain for the first step of the universal coupling fork. I'll just click OK, and I'm going to have a symmetric way, and the total height of the coupling would be like, I'm going to consider as 28 plus 106 plus 28. So the total length is equals to 28 plus 106 plus 28. It is 162 mm. Okay, fine. So next I'm going to have it in the front view, and I'm going to create a sketch for remove material in extrude option. So this value will be 28 in the top, 28 in the bottom, 106 in the middle. And I'm going to select a references with this straight line, and I'm going to delete this references which is not required for us. I'm going to create a center line here and a center line here, and I'm creating a rectangle where this distance is like 106 in symmetric, and this distance is not at all a matter. The only thing we need to ensure is this distance should not be less than the length of the fork. So if it is beyond the length, it is fine. I'm going to consider as 95 mm and this value as 106. Yeah. So just click OK. It is going to extrude on the both the sides. So we are selecting symmetric, extrude it to the maximum length, and click on the remove material. So here we can able to see the fork of the universal coupling has been generated. So the next thing, we are going to have a hole here. The diameter of the hole and the portion of the hole will check in the drawing. So the diameter of the hole is equals to the diameter of the pin on column. So here the diameter is 30 mm, so the hole also will be like a 30 mm. It is exactly placed in the concentric of this external radius. So we'll consider the same way. I'm going to click hole command, selecting the surface. I'm considering it with this same planes, and the diameter of the hole is 30 mm, and the distance is considered as 0. So it will be placed, and I'm going to select until to some references, and that references I'm selecting as this surface as a reference one. So the hole will be generated from the starting point of this surface to end point of this surface. So here hole has been generated. The next only the thing pending in this fork is to create a shaft here. The internal and external diameter of the shafts is like 50 mm and 88 mm, and along with that they have a keyhole to make a connection. So the height of the shaft center point is 81 mm from the top surface. So in the same way, I'm going to click on the extrude command, selecting this surface, moving to sketch view. I'm clicking on center lines. Execute the center line. I'm taking this as a references. Okay, actually this reference is not required because we are going to constrain the center of the shaft with the help of height from the top surfaces. So we need this top surface as references, and this surface is not required. Moving to sketch view, this height distance is considering as 81 mm, which is obviously the center of this total distance, and length is the diameter of inner shaft is 50, and the outer diameter is equals to 88. And also there was a keyhole in some of the CAD models. The keyhole operation will be executed in a separate extrude command with a remove material operation, but here I'm going to incorporate that feature in this shaft command itself. So I'm going to select a rectangle here, adding a rectangle which is symmetry in the way. This distance would be like 5, and this distance would be like 10, and I need the distance from here to this one like 5. Now I'm going to delete the unwanted lines, delete segment, delete these lines. I'm going to corner this connecting points. So I hope this would be fine. Okay, the diameter, this is 81, this is 86, and this diameter is 30. Oh sorry, this is to be as a diameter, value as 50, and I'm just click OK. This length is completely considered as 130 from the starting point of this shaft. This we have reduced as 80, so this I'm going to give as 80. This length of the shaft is not mandatory in this particular case because we are not going to connect any other external parts from this here. So this is the fork which we have created. In case if you're feeling to have some other edge round radius for this fork, you can add it. For example, a small radius in this top and bottom of the shaft, which will be value of 3 or 2 will be fine to looks, as well as if you wanted to add a radius in this corners like that. But this is not mandatory as per the drawing which we have taken for references, so I'm going to skip these options, but for your information I would like to share this. So please remember, if you wanted to have any radius in this kind of areas, you can add it, because whenever you're making a design for the cast, there is a rule, there should not be any sharp corners. That's it. So let me save this component, save as backup. I'm going to save it as in a desktop under a new folder, Universal Coupling. The fork has been done. Next I'm going to go for the second component, which is central block. I'm going to create a new part, central block below CK. So central block part is created. In this also I'm going to use two different extrude operations. One extrude is for the front view and one extrude is for the top view. The only distance between this center axis to this center axis is 38 mm. Apart from that, both the shaft has 53 53 symmetric in top and bottom as well as front and back, and the diameters is like same 56 and 30. The only it changes, the 38 is the center distance. So first I'm going to execute the front plane surface. So I'm going to select circle command and I'm going to draw two circles, and also I have forgotten to add the center lines. Let me add it. So the diameter of the shaft should be like 30 and 56. The inner diameter is 30, our external diameter is 56, and this should be get a symmetry of the distances 53 on both the ends. So 53 in option 2, inside 2 also variable, I'm going to have a distance of 53. So first front view of the center core block is being done. Next I'm going to execute for the top plane. I'm selecting this top plane. So here we have this references. From this references we have a distance as 38 mm, which we have shown in the drawing. So I'm going to select a center line, and this center line is going to be considered as 38 mm distance. Let me verify this once again. The center distance is 38 mm. Yeah. So this 38 mm distance, I'm going to create a circle. Also we'll have a thing here. Internal diameter as 30, external diameter as 56, 30 as a distance, and this distance is as 53 on side 1 as well as 53 on side 2. So here we can able to see a collar has been created. I'm going to click on the front view here, as well as this collar has been created. So here we have created the CAD model for the central block. Now we can able to see there is some material interaction between these CAD models. Let me show you in the top view. Here we can able to see this material has been connected, as well as for the front view. So just to remove this area, I'm going to use another extrude command to remove the material in this. I'm going to select this top surface as a reference. I'm going to select a circle, and I make the circle which is equals to the internal diameter, and I'll switch that to the distance of to a references and click on remove material. So this you can able to do even in a whole command without adding the internal diameter sketch in the first extrude itself. But in case if you made it in this way, you can, no worries, you can remove that material using another extrude command. I'm going to select this circle as also as a references, so that I will get the center point. Selecting the center point, click on this, click OK. I'm going to select two references. Until this, I'm going to remove the material. So here now you can able to see that particular material has been removed on the both the sides, and we can use this central block for the assembly. I'm going to save this also. So the next part I'm going to create is called as a pin. Pin is a normal component that total distance is 180 mm, which has 12 mm depth to have a hole, and 30 mm as the diameter, and 50 mm diameter, and 10 mm width as the collar as the head. So to do that, I'm going to create a new part. I'm going to name it as pin. Click OK. I'm going to create this in a revolve command in a single feature. So selecting a revolve command, selecting the front plane, I'm moving to this wave, adding an axis line to this vertical and center line to horizontal. Yeah. So now I'm going to create a sketch. The center line is not yet added. Yeah. So this is the half cut section view sketch for the pin. Now I'm going to define the dimensions here. This height is considered as 180 mm. This is considered as 30 dia, and this head is considered as 50. Height of the head is as 10 mm. And I'm going to click OK here. So the pin is generated. The only thing pending is you need to create a hole. To create a hole command, I'm selecting this plane. So the next only pending feature is to create a hole. To create a hole, I'm going to click on the extrude, since I don't have the tangent plane. In case if you need, you can create a tangent plane, then you can proceed for the hole. I'm going to use the extrude command here. I'm going to have a circle in this axis which is that of 12, and the distance from the top surface is also equals to 12. Let me verify the diameter value once again. It is, I think so, only just 6 mm. Click OK. Let me create a remove material on both the sides symmetrically and drag the length, remove it. Yeah. So the whole diameter size is just equals to 5 mm to 6 mm. Here I'm going to have the value as 5.5 for the diameter of the hole. So the pin is also generated. We're going to save this video in desktop universal coupling. I'm saving this video. So the next part we are going to create is a collar is also just like a washer. We are going to have a thickness of 12 mm and the diameter is 5.5. The outer dia is 50, internal dia is 30, which is same as pin. Going to select create a new part, name it as collar, click OK. For this also I'm going to use a revolve command, selecting the revolve, selecting the front plane, move to switch sketch view, select an axis for the vertical line, center line for the horizontal one. Now I'm going to have a rectangle here where the internal diameter distance will be like 30, external diameter is 50, height is 12 mm, and just click OK. So you can see a collar has been generated. The same way, only pending thing is hole feature, that also I'm going to create in extrude command as same as what we did in the pin. I'm going to have this for this center. The total distance is 12. I'm going to have center as 6, diameter as 5.5. Click OK. Extrude the length to some maximum value. Make it as symmetric and click on remove material. So the hole in the collar is also being generated. I'm going to save this part. OK, fine. So we'll close this. The only part pending is the tapper pin. For the tapper pin, I'm going to use 5 mm as a minimal diameter, 6 mm as a maximum diameter, and 60 mm as the length. Tapper pin made up of mild steel. So we'll check out this. So to create this, I'm going to click on the new part, name it as tapper underscore pin, enter. So to create a tapper pin also, I'm going to use a revolve command, selecting the front plane, moving to sketch view, creating a axis line for the horizontal. Oh, sorry, axis line for the horizontal and center line for the vertical. So I'm going to have a tapper structure here. Since we are going to have maximum diameter as 6, minimum diameter as 5, and the total length is 60. Since we are controlling the distance as 60, we don't want to control about the angle. And just click OK. So a tapper pin has been also generated. So here we can able to see the tapper pin. This is also I'm going to save in the same folder. So let me showcase one by one part. The first one is fork, which we have created. Let me color it as in the green for one, and save this. Next we'll open the central block, which will be colored in yellow. The third part is a pin, which will can be colored in red or a dark red. Yeah. And the fourth one, which is a collar, which will be colored as a blue. And the fifth part is the final one, tapper pin. So the tapper pin, I'm going to color it in steel. So these are the 5 parts which is required for the universal coupling. So next we are going to see the second section. The second section is creating an assembly of universal coupling. So we are going to start from the scratch. I'm going to create a new file, an assembly file, and naming it as universal coupling, and click enter. So in this, as I mentioned in the earlier starting of the video, the third section is for a mechanism. But for the mechanism assembly, I'm going to demonstrate once again. This is for a non-mechanism assembly. So I'm going to give constraints as how we require for the drawing. So first part, I'm going to click on the assembly. In sessions, we have fork. So fork, I'm going to have a constraint as default. The second part I'm going to constrain is a central block, which is going to have a coincidence from circle to circle as well as surface to surface as a coincidence. So the third part which we are going to assembly is another fork, because fork is two quantities as per the bill of materials. So next I'm going to select this fork. I'm going to turn it in the opposite direction, selecting the hole which is coincidence with this particular collar, sorry, central block, and surface to surface contact as a coincidence. The third one, I'm going to assemble the collar, sorry, the pin. Pin is going to come in the mid of the portion in the central block as well as here. So pin also has two quantities in bill of materials. Going to have a constraint coincidence with this shafts. The second one is coincidence surface to surface. The third one, once again, the pin for the another central block, shaft to hole coincidence as well as surface to surface. The fourth part we are going to constrain is collar also having a two quantities as per the bill of materials, which constrains this both surface to, so the hole to hole is been, hole to shaft has been has a constraint, and the second one is I'm going to have a coincidence between surface to the surface as a coincidence. And also we need to have another one coincidence where 1 degree of freedom has not been arrested, which is this rotational view, so that I'm going to have a orientation between this hole to the hole in the pin oriented. So this is the perfect coincidence and perfect uh, locking the degrees of freedom, arresting the degrees of freedom, so that we'll have a very rigid connection in assembly. Next, I'm going to have another collar, the same way, hole to shaft coincidence and the surface to surface contact, as well as coincidence, as well as the third constraint for hole to hole orientation. New constraint, hole to hole orientation. So this also has been arrested in 360 degree all the degrees of freedoms. The final part which we are going to add is tap up pin. So the tap up pin also I'm going to have a coincidence of surface to surface, I think this is, and another coincidence is like this edge to surface to this surface. I'm going to have it as a distance. In case if you have any other constraint required for this particular assembly, you can use that method. For example, you can constrain the mid plane of the tapper pin to the mid plane of the collar or pin or fork, anything you want. So this I'm going to have a 12 mm or like a 13 mm distance. Yeah, 14 mm distance looks so fine. So another tap pin also going to get assembled in this area. The same way I'm going to have a coincidence to hole, sorry, hole to shaft, and the distance of surface to the fork could be like, would be as a parallel. Sorry, this is something is missing. Okay, here the reason is the collar pin has not been constrained in all degrees of freedom. So the collar has been oriented the pin. Pin is not oriented the collar. Collar has oriented the pin. So the only option here is I'm going to have a constraint like plane to plane, where I'm going to have a contact between a new constraint from this surface to shaft distance so makes an invalid constraint. So before this I would like to have a rigid connection for the pin as well. So let me modify the pin first. I'm going to select this pin, remodify this. I'm going to have a new constraint where this particular degrees of freedom is not yet arrested. So this I'm going to use shaft to sorry plane to this distance in a parallel way. So it will be as considered as a full constraint, and I'm going to regenerate. So model is also has been fully constrained where I'm having a hole here. Now the final tapper pin going to get assembled. Select a tapper pin. The surface to surface has been got coincidenced, and also I'm going to have a distance constraint from the surface to surface as 14 mm. Yeah. So here you can able to go through all the parts has been assembled for an universal coupling. I would like to recall all the parts once again. The first part is fork, which is available on both the sides. So the number of components for the fork in bill of material is 2. The next part is central block, which is in the mid area. The third part is for the pin, which this is also has a 2 quantities. The fourth part is collar, which is also has a 2 quantities, and the last and fifth part is tap up pin, which is also has 2 quantities. So this is how guys you going to create a assembly constraint for the universal coupling. So next we are going to move to the third section, which is going to create a mechanism. So for that I'm going to create a new assembly file, and I'm going to have a universal coupling underscore mechanism. Click OK. So to constrain a mechanism, the engineering connections or the constraints which you are going to give for the parts is completely differ, which we given in the traditional way. Oops, sorry, I have created a part by mistake. Let me create an assembly first. I'm going to create a new file, create an assembly, universal coupling mechanics. Click OK. So a new assembly file has been created. Now we are going to start from the basic. Here none of the components won't have constraints, rigid connections, or default positions, nothing. Everything will have in a pin concepts. First I'm going to select a fork. For this I'm going to have a pin connection. In pin connection we are going to define two constraints. One is for the axis alignment and another one is for the transition on the distance basis. So for this first we need to have an axis. Since axis we don't have, first we are going to create an axis. For that I'm going to create an axis line this way. Next we are going to assemble the fork. So for the fork we are going to switch the connection to pin mode. In pin mode we are going to have a connection axis alignment as this to this. So in this way axis has been aligned. The next thing is constraining the planes or the transition distance. For that I'm going to select this plane to this plane as a coincidence. This is fine. So click OK. Here you can able to see a box about the fork name, which makes this connection has not made as a rigid connection, as well as this connection is not made as a undefined constraints. So there is a box with a dot in middle which defines this is made for with some other special connections. Next we are going to have a central block. For central block also I'm going to use the same pin concept, where I'm going to make axis alignment this axis to this, as well as the transition distance as surface to surface. I'm going to have this surface to the surface and just click OK. The third part also the second fork which we are going to have in the pin connection. Select the pin mode and rotate this. Have an axis alignment, and for the transition I'm going to have surface to surface. Can't able to select this. Okay, since the axis alignment I have made it for the middle one, I need to redefine this axis alignment, where the axis alignment will be like the whole axis to this central block axis, and the transition would be like central block face to the fork face. So in this way, the third part, I'm going to assemble a pin. Pin is also going to have a pin connection, which is the actually real one. Selecting this axis to this axis and constraining the surface here to here. So the first pin has been aligned. Second pin also we're going to make it in the same way. A pin connection, selecting this pin to this axis and the distance from here to here. I'm going to flip it in the opposite direction. So the fourth part which we are going to have is a collar. Collar is also going to have it in a pin connection. Selecting this pin, and I'm going to select axis alignment here to here, and the transition as surface to surface here too. Okay, I have not selected the pin, and this is a collar. I've selected. Okay, now I need to select the surface to this surface to get flip. This is not constrained, so I'm going to have a distance of the front view, distance of 6 mm, so it will be perfectly aligned. The same way, I'm going to have another collar, axis to axis alignment from here to here, as well as the transition. Sorry, this should be as a coincidence. Oh, I didn't select it as a. The second one is surface to surface with a distance of 6 mm minus 6. Okay, so the last part which we are going to constrain is tap up pin. For the tap up pin also, I'm going to have the same connection as pin. I'm going to have a, oh sorry, I have selected the main normal pin. I need to select a tap up pin. For the tap up pin also, I'm going to select a pin connection. The first one is for the axis alignment from this axis to this axis, and I'm going to have a transition as this plane to collar plane. That's a distance. The another tap up pin is going to get assembled. This is also I'm going to get it in a pin connection, enable the axis here to this axis, and the transition like plane to plane, this plane to this plane in a distance mode, BS 30. So in this way we have constrained all the parts in this. Please make sure whenever you're going to give a special connections like a pin or a slider like this, once you have selected the first connection between two parts, the second connection also should follows the same parts. When you're giving a rigid connections, it is not mandatory in Creo Parametric. First, axis to axis alignment you can give to the collar. Second, surface to surface contact you can give to tapper pin to fork. But when you comes to a mechanisms, simulations, or kind of a special connections, please make sure the both the connections follows the same two parts. We can't able to select some other parts. So this is how we have connection made for the mechanisms. Next we are going to select the applications. In applications, there is a section called as mechanism. We are going to select the mechanism. In this mechanism, first we are going to derive a servo motor which is required to run the systems. So selecting a servo motor, I'm going to apply in this direction. I'll just make this profile driven quantity as a angular velocity, not as an angular position, and the value unit of the angular velocity as degree per second, where this value we are going to modify based on the speed required to make the universal coupling to rotate. For example, initially I'm going to give 5 degrees per second and just click OK. So in this mode I have created a servo motor here. Next we are going to see how this simulation is going to work. To see that, you can go to mechanism analysis, click on that. You can give the start time and end time. In case if you wanted to make it in a length and a frame count or rate count in the frame count, you can select any kind of these options, but it is mandatory to have minimum two parameters, either length and rate, length and frame count, or rate and frame count. Such a way I'm going to use length and rate. The initial start time will be as a 0 and the end time I'm going to give it as 50, and I'm going to click on the run. So here you can able to see this universal coupling mechanism is rotating as how it will works in the applications. So in this way you can able to analyze simulation and you can verify how this mechanism assembly is going to be work in the real-time examples. In case if you wanted to increase the value of this angular velocity, of course you can click on cancel, go back to servo motor which we have added here, click on edit definition, go to profile details, have a value as 25 and click OK. So now we have added the servo motor angular velocity value as 25 degree per second. Once again switch back to mechanism analysis, add a end rate as I'm going to have it as 75 and start time will be as a 0. Now I'm going to click on the run. Before click on the run, you can just move, snap or drag the model in which view you wanted to verify it. For example, if I made it in the front view or a view normal to this, you can select anything like this and you can create a mechanism analysis. Sorry, I'm going to have 75 as in and click on run. So here you can see in the particular direct front view how your mechanism is going to work. And you cannot able to skip this. Once you have started this run button, it will take time to complete this frame count until this end bar. Then only you can do any other operations if you need it. So once again I would like to have a change in mechanisms. For example, I'm switching the value as very high, like 200 degrees per second. So in this we can't able to even identify whether this mechanism is properly functioning or not. I'm going to have just a 50 frames and run. So here see, it's just collides. And also here you can able to see there is some mismatching in the axis alignment from the left fork to right fork. The right fork axis is somewhat misaligning with the left fork. This you need to verify in the assembly view so that you can able to rectify these solutions. As of now, the solutions might be on the central block distance. So guys, I hope you enjoyed this video and you have learned this video. This is how we are going to create a part by part universal coupling and its assembly section, and also how to give a mechanism for universal coupling. So I hope you guys has got understand and a clear view on this. In case if you have any doubts, please post your comments in the comment box. Sure, definitely I will reply. And also you can ping me on any other social medias. The social media handles, the link has been given in the description. Please check it out. And if you like this video, please like, comment and share along with your mechanical friends and the design friends who is very much motivated to have a design like this. So see you guys in the next video. Until that, catch up you. Bye. Thank you.